Hello everyone, welcome to a guide for aspiring engineers on one of the biggest decisions you'll make in your academic journey, which is choosing the right engineering major. With so many options out there, from mechanical to electrical to biomedical, each field offers its own unique blend of challenges and rewards. This video will walk you through essential tips to help you make an informed choice that aligns with your skills, interests, and career goals. Before diving into any specific major, it's helpful to understand the core engineering fields and what they focus on. Mechanical, civil, electrical, and chemical engineering are some of the oldest and broadest areas of engineering, each covering distinct industries and problem-solving approaches. Mechanical engineering is one of the broadest engineering fields, focused on designing, analyzing, and improving machinery and mechanical systems. From automotive parts to industrial machinery, mechanical engineers work on projects that involve forces, motion, energy, and thermodynamics. They play a critical role in industries like aerospace, automotive, robotics, and manufacturing. Civil engineering deals with infrastructure and construction, aiming to build safe and efficient systems like bridges, roads, dams, and buildings. Civil engineers use knowledge of geology, materials science, and physics to solve structural challenges, improving urban areas and managing resources. Careers include urban planning, structural engineering, and transportation engineering. Electrical engineers work with electronics, electricity, and electromagnetism, focusing on circuits, power systems, and signal processing. They are essential in developing technology in industries such as telecommunications, energy, and consumer electronics. Careers can range from designing power grids and renewable energy systems to developing cutting-edge electronics like smartphones and medical devices. Chemical engineering focuses on converting raw materials into valuable products using chemical processes. Chemical engineers work in fields like pharmaceuticals, energy, environmental management, and food production. They play an essential role in designing processes that are efficient, safe, and sustainable, often working in labs and large-scale production facilities. To better understand these core disciplines, let's look at some real-world examples. A mechanical engineer at Tesla might design and test components for electric vehicles, ensuring they meet performance and safety standards. Another might work on renewable energy systems, such as wind turbines or solar panels, to create more sustainable energy solutions. Civil engineers might work for a city government, designing earthquake-resistant infrastructure in seismically active areas like San Francisco. Others might specialize in flood management systems, developing better ways to protect communities from extreme weather. An electrical engineer at a company like Apple might design circuits for smartphones, while another in renewable energy might work on solar power systems that optimize energy conversion and storage for homes and businesses. Chemical engineers in the pharmaceutical industry may help develop and scale up the production of vaccines, ensuring safety and efficiency. In energy, they might work to improve battery storage technology for electric vehicles or find cleaner ways to produce fuel. As technology advances, new branches of engineering continue to emerge. Environmental engineering, for example, focuses on developing sustainable solutions to environmental challenges, such as water treatment, waste management, and pollution reduction. Environmental engineers work to minimize the impact of industrial processes on the environment and find ways to manage resources responsibly. Software engineering, while not traditionally classified with the Big Four fields, is now one of the most in-demand disciplines. Software engineers create applications, algorithms, and systems that power nearly every industry, from healthcare and finance to robotics and autonomous vehicles. With the rise of AI and machine learning, software engineers are also shaping how technology can improve decision-making across various fields. Choosing the right engineering major begins with a clear sense of your interests and strengths. Reflecting on what excites you can make a big difference in selecting a path that keeps you motivated, inspired, and engaged throughout your studies and career. Do you find yourself drawn to the mechanics of how things work, or are you passionate about solving environmental issues? Understanding these preferences can steer you toward a major that aligns with your curiosity. Start by exploring your personal interests as they relate to different engineering fields. If you're captivated by the intricacies of machinery and love hands-on projects, mechanical engineering could be a great fit. Mechanical engineers often work on the design, testing, and improvement of mechanical systems, so an interest in robotics or automotive design could be a sign that you'd enjoy this field. On the other hand, if sustainability and renewable energy spark your curiosity, you might be more interested in environmental engineering or energy-focused chemical engineering roles, where you can work on projects that reduce environmental impact. Some interests also connect to specific majors in ways that might surprise you. For example, if you love gadgets and enjoy understanding how they function, electrical engineering could be a natural choice, as it deals with circuits, electronic devices, and power systems. If programming or building apps is your passion, then software engineering might be a natural direction, as it combines creative problem-solving with coding to develop everything from mobile apps to machine learning algorithms. One way to gauge your interests is by trying out different engineering-related activities outside the classroom. Participating in extracurriculars like robotics clubs, coding workshops, or science fairs can give you hands-on experience in various fields and help you determine what resonates most. Many engineering programs also offer introductory courses or electives that give students a taste of different majors, so enrolling in online courses through platforms like Coursera, Udacity, or Khan Academy can be a great way to start exploring. Summer programs or internships are another valuable way to explore potential majors. Many universities and companies offer programs that allow high school and early college students to work in labs, join project teams, or assist with research in different engineering fields. These experiences help you understand what real-world engineering work looks like, allowing you to see whether your interests align with the tasks and challenges of a specific discipline. Taking the time to explore your interests will help clarify which engineering major aligns with your passions. This step ensures that you enter your studies with enthusiasm and a clear direction, making your journey in engineering even more rewarding. Now let's move to considering industry trends and job prospects. Choosing an engineering major isn't just about following your interests, because it's also about understanding where the industry is headed. The job market for engineers is evolving fast, especially in fields driven by technology, automation, and sustainability. By considering industry trends, you can make a more informed choice and set yourself up for success in a rapidly changing landscape. Today, some of the highest demand fields include software engineering, electrical engineering, and environmental engineering. As industries become more tech-centric, software and electrical engineers are needed to develop and maintain the digital infrastructure, supporting everything from healthcare to smart cities. Similarly, environmental engineering is growing due to the urgent need for sustainable practices and renewable energy solutions to combat climate change. Mechanical engineering also remains versatile and essential, with roles in manufacturing, aerospace, and automotive industries that continue to evolve with advances in automation and robotics. Long-term job prospects are another important factor. Fields like computer engineering, biomedical engineering, and robotics offer promising career paths, with demand driven by innovation in artificial intelligence, healthcare technology, and automation. The U.S. Bureau of Labor Statistics reports that biomedical engineering, for instance, is expected to grow significantly as the population ages and healthcare technology advances. Salaries in engineering also tend to be strong across the board, with higher averages in specialized areas such as petroleum engineering, AI, and software engineering. While these fields may require specialized knowledge, they also offer rewarding opportunities for innovation and impact. Emerging fields like artificial intelligence, robotics, and bioengineering are gaining attention as they open up new possibilities in both research and applied sciences. Engineers in artificial intelligence develop algorithms that power machine learning, deep learning, and data analysis tools. Robotics engineers create automated solutions that assist in manufacturing, healthcare, and even space exploration, while bioengineers apply engineering principles to biology, working on medical devices, genetic engineering, and tissue regeneration. These fields are on the cutting edge of science and technology, with job markets that are expected to expand as society continues to integrate advanced technologies. Every engineering discipline has its own unique set of courses and required skills, tailored to the challenges and demands of that field. Before choosing a major, it's helpful to understand the core courses you'll encounter and the skills you'll need to succeed. This can help you prepare academically and mentally, ensuring that you're ready for the journey ahead. In many engineering majors, math and physics are foundational. For instance, calculus and linear algebra are staples across almost all engineering programs, laying the groundwork for more advanced concepts. Mechanical engineering students, for example, will delve into courses on thermodynamics, fluid mechanics, and materials science. These courses help them understand the physical and chemical properties that drive mechanical design. Civil engineering majors, meanwhile, focus on structural analysis, geology, and environmental engineering, with an emphasis on the physics of construction and infrastructure. Electrical and computer engineering students have their own set of core courses, including circuits, digital logic, and electromagnetic fields. These areas require a strong command of mathematics and an aptitude for problem-solving in dynamic systems. Software engineering majors might spend more time on algorithms, data structures, and coding languages like Python, Java, or C++. For students drawn to the life sciences, biomedical engineering combines principles from biology and medicine with engineering courses in areas like biomechanics and bioinstrumentation. Chemical engineering majors, on the other hand, focus on chemistry-intensive courses, including organic and physical chemistry, alongside material and process engineering classes. Certain skills are essential for specific fields. For example, mechanical and civil engineering require a strong spatial understanding and the ability to visualize physical structures and forces. Electrical and computer engineers often need strong analytical skills, attention to detail, and proficiency in coding. Biomedical engineers should have a solid grasp of both biological sciences and engineering principles, while chemical engineers need strong lab skills and a deep understanding of chemical processes. Preparing for challenging coursework is key to thriving in engineering. To strengthen math and physics skills, online resources like Khan Academy, MIT OpenCourseWare, and YouTube tutorials can be invaluable. Building problem-solving strategies and practicing consistently can help, as engineering often requires applying theory to real-world problems. Study groups and peer collaboration are also beneficial for tackling complex subjects, as explaining concepts to others can reinforce your own understanding. Getting hands-on experience is one of the best ways to truly understand what an engineering major entails. Internships and practical projects bring classroom learning to life, allowing you to apply theories and techniques in real-world scenarios. Beyond boosting your resume, hands-on experience can help you determine if a major aligns with your career goals and personal interests. Internships provide insights into day-to-day tasks, industry standards, and the working environment for various engineering fields. Through an internship, a mechanical engineering student might work on designing or testing components for automotive systems, while a civil engineering intern might assist on a construction project, learning about materials and structural stability. These experiences help you gain familiarity with tools, processes, and problem-solving approaches specific to your field. Internships also teach soft skills like communication, teamwork, and time management, which are essential for succeeding in any engineering role. If an internship isn't available yet, there are numerous ways to gain hands-on experience. Entry-level projects can introduce you to skills needed for different engineering fields. For instance, building and programming a small robot can provide valuable exposure for students interested in electrical, mechanical, or robotics engineering. Coding projects, such as developing simple applications or scripts, can be great for aspiring software or computer engineers. Chemical and biomedical engineering students could consider conducting small experiments or simulations to understand reactions and material properties. These projects not only help you build a skill set, but also demonstrate initiative and passion to future employers. Finding internship opportunities and networking within your chosen field can make a big difference in securing valuable experience. University career centers are a great resource, often hosting engineering career fairs and connecting students with alumni networks. Joining engineering clubs or professional organizations like IEE or ASCE can also open doors. LinkedIn is useful for connecting with professionals and following companies in your field, while platforms like Handshake or Indeed often list entry-level internships. Don't hesitate to reach out directly to companies or ask professors for leads. They can often connect you with opportunities that align with your major. When choosing an engineering major, it's tempting to follow only what you're most passionate about. However, it's just as important to consider practical factors that will impact your long-term career satisfaction, such as job stability, work-life balance, and market demand. Striking a balance between passion and practicality can lead to a career that is not only fulfilling, but also sustainable. Balancing your personal interests with practical career goals is essential in any engineering field. For example, if you're drawn to environmental engineering because of a passion for sustainability, it's helpful to also research the types of roles and industries where demand for environmental engineers is growing. By understanding where these opportunities are and which skill sets are in demand, you can pursue your interest in a way that aligns with industry needs. Similarly, someone with a passion for aerospace engineering should consider the job availability in the field, which may be more concentrated in certain regions or organizations, compared to broader fields like mechanical or civil engineering. It's also helpful to explore ways to align your passion with fields that offer stable opportunities. For instance, renewable energy engineering is rapidly growing as the demand for sustainable solutions increases, offering both personal satisfaction and a strong job market. Biomedical engineering is another field with increasing relevance as medical technology continues to evolve. These examples show how you can pursue meaningful work that also aligns with market trends and growth areas, combining your interests with practical opportunities. Managing expectations and setting realistic career goals are essential for finding this balance. Careers in highly specialized fields, like robotics or artificial intelligence, may require advanced degrees or extensive experience, so understanding the steps you need to get there will help you prepare for the path ahead. Having a clear idea of what the job entails and the effort required will also help you avoid burnout and keep your goals realistic. Talking with professionals in the field, using resources like informational interviews, or connecting with mentors can provide valuable insights into the practical realities of various engineering paths. Choosing an engineering major can feel like a permanent decision, but the reality is that many engineers shift paths as they grow and explore new interests. Engineering is a diverse and evolving field, and the skills you develop will open doors to a variety of opportunities. Embracing flexibility can help you adapt to changes in your interests or industry trends, setting you up for a more resilient and rewarding career. Many engineers find themselves transitioning between fields as their careers progress. For example, a civil engineer might move into environmental engineering to focus on sustainability, or a mechanical engineer might venture into robotics or software development to keep pace with industry changes. Stories of engineers who started in one field but thrived in another are common and underscore the versatility of an engineering background. These professionals demonstrate that a willingness to learn and adapt can open up new and unexpected career paths. Remaining adaptable also means committing to continuous learning. Even after choosing a major, staying current with new technologies, tools, and methodologies is crucial. Whether it's through online courses, certifications, or attending industry conferences, ongoing education helps engineers pivot when necessary and keeps them valuable to employers. As technology advances, the engineering landscape will continue to change, so cultivating a mindset that embraces growth and adaptability is essential. Above all, remember that it's okay to follow your instincts, even if they lead you in a new direction. If you realize after a few years that another field excites you more, don't be afraid to pivot. Many engineers successfully transition between fields, bringing valuable skills from one area to another. Flexibility allows you to respond to what's best for you in the long run, whether that's adapting to a changing industry or pursuing a new passion. So, as you choose your major, keep an open mind. You're building a foundation that can evolve with you as your career progresses. Choosing the right engineering major is a big decision, but it's also an exciting step toward your future. Take your time to explore, ask questions, and remember that whatever path you choose, engineering is full of possibilities. So, embrace the journey ahead, stay curious, and keep pushing boundaries. Good luck on your path to becoming an engineer, and don't forget to subscribe for more insights to guide your way. See you in the next video.